So in this video, I'm going to go through all of the different types of blood. This is a graph showing the different types of blood, and the different, like how common it is in the world. I'm not exactly sure what my blood type is, but I do know that I'm most likely either O positive or A positive, which happen to be the most common in the world, which I mean is not that exciting, but at least I have options. So what we're going to do is we're going to go through all of the different types of blood, what the red blood cells look like, the antibodies that are present, and the antigens that are present in the on the cell. So first of all, we'll start with type A blood. So if this is the red blood cell in type A, we're going to say that the antigen markers that are present in type A, let's say that they're kind of like a square shape. So you guys can probably draw a lot nicer in your notes than I can with this pen, but little squares all the way around the red blood cells. And that's what A is going to be recognized by. So the antigens, which are the markers, are the ones that are square. The antibodies are Y-shaped proteins. So I'm just going to leave it like that for now, and I'll come back to that. So B blood is a little bit different. B blood, instead of being square, it's a little bit more triangular shaped antigens that are all around the red blood cell. So the antigens is a little triangle, and the Y-shaped protein would look like this. So if you have type A blood, it wouldn't make sense to have an antibody that matches the type A blood, because then we would constantly be fighting against our own blood type. So instead, we have antibodies in type A blood that match with type B. So it's called anti-B type antibodies that would have little triangle pieces on the antibodies that would match with type B blood instead of type A. So if I came in contact with type B blood, my body would know that it's not from my own body, and that would cause some problems. Same with if I have type B blood, I'm not going to constantly be fighting against my own blood. So I have anti-A antibodies, which would have squares on them to match with the square antigens of type A. So again, if I come into contact with type A blood, that's going to cause problems. I don't have problems with my own blood. I have problems with other blood types. If I have type AB, type AB is a combination of both A and B antigens. So squares and triangles. So they have neither of the antibodies, because then they would constantly be fighting against both of the types of antigens that they have. And O has no antigen markers. It's just a plain red blood cell that is blank. So because they have no antigens, they have two different types of antibodies. They have the anti-B antibodies, and they have the anti-A antibodies, because they are going to fight against AB, B, and A blood, because it's not the blood type that they have. So anti-B and anti-A antibodies are the ones that they have. So that's the chart that we're filling in. With that being said, because this type of blood, type AB, has no antibodies, this makes them the universal receiver, which means that they can get blood from any other type of blood. And because this type of blood has no antigen markers on it, it can give blood to any other type of blood. So it's the universal donor, which I'll explain a little bit more on the next slide. So speaking of the next slide, let's go to it. So if you come into contact with blood that is not your own, the process that happens is called agglutination. So basically it's kind of like clotting of the blood, where it clumps up. And this happens because of the antibodies that are present in your blood that are fighting against blood types that are not your own. So basically, back in the day, before they knew how blood worked, they would give blood transfusions from one person to the other and end up killing people. And they didn't understand why. And it's because of these different types of blood that you have. So we got to make sure that we're not having agglutination happen, because obviously that's going to be a really bad thing. There's also another piece to this puzzle. It's called the Rh factor. So you're either positive or negative. So on top of the antigens that we have, the A or the B antigen, you can also be positive or negative. So if you're positive, that means that you have it. If you're negative, that means you don't have it. So if you were like A, for example, let's say you're A positive, your blood would actually look like this with the little the Rh antigen there as well, if that makes sense. If you were just A negative, you wouldn't have any of those extra things. Those would not be there if you're A minus or A negative. Okay, so that's another extra antigen that they figured out later after they named the A, the B, the AB, and the O, because they continued to give blood transfusions to people and they were still having the agglutination process happen. So they had to name this. And it's named after the rhesus monkey. That's why it's called the Rh factor. So this becomes really interesting in certain circumstances. Like, for example, if we have a pregnant woman who is Rh negative, so any blood type that's negative, so A minus, A negative, B negative, AB negative, or O negative, she has a negative blood type, but it says in this certain circumstance, her baby is Rh positive. Okay, so inside of her uterus, as she grows her baby, it's Rh positive, and that's no big deal when that baby is being developed. But the issue with that is once the baby is born, she now has antibodies that are basically going to fight up against Rh factor because she's negative. She does not have that factor in her blood, but now she has the antibodies that are going to fight against it. So if she gets pregnant a second time, sorry, let me just zoom down here. So in the second pregnancy, she potentially, if she has a positive blood type baby again, she could potentially cause that baby to no longer be safe. Okay, so that baby could be miscarried or be stillborn or born really, really, really premature due to this. So to get around this, what they do is they give the mother medicine that suppresses her immune system a little bit during this time, stops the antibodies from building up, and then so that she gets pregnant a second time, it's not an issue. So my sister-in-law, she's O negative, and both of my niece and nephew are positive. So she would have had this issue with my niece as the second born, where maybe my niece wouldn't have been born because if she didn't take this medication, her antibodies would have fought against my niece's blood and thought that it was a foreign invader and ended up maybe killing it. So thankfully, medicine has progressed past this and we can get around this and cause us to not have this be a problem. So any woman that is negative blood, they just give the medication to while she's pregnant, and doesn't matter what the father's blood type is. They just do it just to be safe, so they don't have to ever worry about this. So those are our types of blood. This is kind of the most important thing that we did. Okay, knowing what the antibodies and the antigens are in each, and that's kind of what you're going to be tested on in your drawing quiz.